In this video, we are going to be doing the power rule in calculus. So, the power rule is just the derivative of any value of x to the power of n. So, the power rule states that d over d of x to the power of n equals n times x to the power of n minus 1. So yeah, that's the power rule. So let's get some questions going. So what is the derivative of x to the power of 5? Take like 10 seconds to solve that question. Okay, so if you did that question using the power rule, we'd bring the 5 down, multiply by multiply by x, and raise it to the power of 5 minus 1, so we'd get 4. Okay, now let's try another question. In fact, here are 3 questions. x3 squared and 1334. So yeah, solve that. Hang on, let me fix this. Yeah, so solve those questions and take like a minute for all of them. And yeah, let's get started solving. So this would become 3 times x to the power of 2, 2 times x to the power of 1, so just 2x. And this would be 1034 to the power times x to the power of 1033. So yeah, that is the power rule. Now there are some other nuances. So for example, how would you do the derivative of the derivative of 5x squared? So take a moment and understand, like, what do you think you would do? So if you still haven't figured out what you would do, there is another formula. So if we bring down this formula of the power rule, so we have x times n, right? So now just think about this as alpha, so that's the coefficient. That's a very bad alpha. So imagine that's alpha, right? So alpha is our coefficient. So what we need to do is basically so we already have n times x. So we do alpha multiplied by the original power rule. So alpha times nx times to the power of n minus 1. So this will just be 5 times 2x, which would equal 10x. So yeah, that is the power rule with coefficients. So let's do some questions. (67 to the power of 67, 32 to the power of 32, or 23, because I actually wrote 23, and then 34 to the power of 39. So take some time to solve these questions. And yeah. Okay, hopefully you've spent some time. So let's get started. So this would be 67 times the original power rule, which is 67 times x to the power of 67 minus 1. So this would equal 4489 x to the power of 66. On to the next question. So we have 32 times the derivative of 23 times x to the power of 22. So this would equal 736 x to the power of 22. And then finally, 34 times 39x to the power of 38. So 1326x to the power of 38. Yeah, and those are some derivatives with coefficients. Now let's move on. So those are just basic power rules. So what is the derivative of, these are just some exceptions. So what is the derivative of 1000, just writing a random string of numbers. Yeah, what is the derivative of 13,848,348? So since there is no x, what happens is we just do, so let me show you. So then this would just be equaling to 1,300, 13848 x to the power of 0. And then when you apply the power rule to this, you'd get, so 0 times, so this number, times 0 times x to the power of 0. Since there is a 0 here, everything that you multiply by a 0 becomes a 0. So this just becomes 0. So basically, the derivative of any constant value is always going to be 0. Okay, let's move on to some harder questions. What is the derivative of x cubed? X to the power of -3. Yeah. So take some time and apply the power rule. Okay, hopefully you've spent some time. So what happens is this goes down here. So it'd be -3x to the power of -3 minus 1. So -3x to the power of -4. So the answer is -3x to the power of 4. And this is our answer. Whatever. So let's get to some harder questions. So what is... I'll let you guys do a question on you by yourself. So what is the derivative of x to the power of negative 67? Okay, hopefully you've paused the video and you've solved the question, so let's get to it. So this would be negative 67 times x to the power of negative 67 minus 1. So we have negative 67 x to the power of negative 68. So this would be negative 7 over x to the power of 68. Okay, and that is our answer. Okay, on to another question. So, what is the derivative of let's see, what could we ask? Oh, what is the derivative of 1 over x squared? So yeah, take some time and solve that. Okay, hopefully you've paused the video and let's get to it. So, if you know your exponential rules, you know that anything in the denominator, so since that's an exponent, since it's in the denominator, if we bring it up to the numerator, we just change the sign. So this would equal x squared, and then if we apply the power, x to the power of negative 2, if we apply the power rule, we get negative 2x to the power of negative 2 minus 1. So in the end, our answer would be negative 2 over x to the power of negative 3. So yeah. Let's do one more rational question. So what is the derivative of see, what can I do? Oh, okay. What is the derivative of 1 over 69x to the power of 420? So, yeah, take some time and solve this question. Okay, hopefully you paused the video and solved the question, so let's get to it. Okay, so this question's gonna take a while. So this is basically just gonna equal to x to the power of negative 420 over 69, and then this is equal to 1 over 69 times x to the power of negative 420, and then applying the power rule and the alpha rule from before, this is just going to equal negative 420 times x to the power of negative 421. And then yes, this does simplify to negative 140. times x to the power of negative 421. So yeah, that's the answer. Okay, so now let's move on to radicals. So what is the derivative of x to the power, the square root of x? So yeah, take some time and solve that question. Okay, hopefully you've paused the video, and let's get started. So, if you also know your exponent rules, you know that, and radical rules, you know that a radical can be changed to an exponent. So, it can be changed to an exponent with a rational value. So, for example, this gets changed to x equals 1/2, and then applying the power rule, we'd get 1/2 times x to the power of 1/2 minus 1. So x to the power of negative 1/2 over 2. So we get 1 over 2 root x. So yeah, that's one question. So let's try another radical. What is the derivative of 69 and x to the power of 67, the 69th root of x to the power of 67? So yeah, take some time and solve that question. Okay, hopefully you solved it. So what would happen is this gets turned to x to the power of 67 over 69. And then applying the power rule, we'd get 67 over 69 times x to the power of 67 over 69 minus 1. So we'd get 67 x to the power of, wait, what is it? To the power of negative 2 over 69. This is over 69. And in the end, we'd get this equaling 67 over 69 x to the power of negative 2, not negative, 2 over 69. So yeah, that's the answer. And for the final question, this is just a challenge question for you guys. There's no harm if you can't do it, but what is the derivative of 5x cubed minus 2x to the power of 4 plus 9? So yeah, solve that. Hopefully you paused the video and solved it. Basically what you need to do is differentiate each thing. So differentiate this, differentiate this, differentiate this. And if you differentiate each thing, you'd get 15x squared plus 8x to the power of negative 5, which equals 15x squared plus 8 over x to the power of 5. So yeah, that's it for power rules in this video. And thank you for watching.